Late 1944, high over Bavaria. A lone P-51 Mustang, piloted by Lieutenant Byers, is entirely separated from his squadron. He isn't just lost, he is hunted. A massive, coordinated Luftwaffe fighter screen is rapidly closing the net around him. According to every tactical doctrine of the air war, a solitary aircraft caught deep behind enemy lines against overwhelming radar-guided interceptors should be torn apart in minutes. It is the pure terror of total isolation against a relentless technological machine. Yet Byers walked away from this lethal gauntlet, and he survived it without firing a single confirmed lethal shot, completely shattering the classic myth of the lone heroic ace. For decades following the end of the war, pulp magazines and Hollywood films sold a very specific, heavily romanticized version of the strategic bombing campaign over Europe. They painted a compelling picture of solitary aces engaged in swirling cinematic dogfights, blasting their way to glory against impossible odds. But when we strip away that post-war mythology and dig directly into the declassified combat logs of the 8th Air Force, cross-referenced with the Luftwaffe's own interceptor grids, a starkly different historical reality emerges. The actual conflict in the sub-zero stratosphere was rarely about who had the faster trigger finger. It was a cold, unforgiving mathematical equation governed by atmospheric physics, strict fuel management, and the invisible, desperate architecture of radio intelligence. We are going to deconstruct exactly how this grueling game of high-altitude cat and mouse was actually fought. This isn't a story of blazing machine guns. It is a profound clash between the romanticized mythology of aerial duels and the brutal, unromantic mechanics of survival, where the margin of error was measured in manifold pressure, gallons of aviation-grade gasoline, and momentary glimpses of cloud cover. The central mystery remains: how exactly did one isolated pilot, cut off from his squadron and operating on critically dwindling fuel reserves, leverage severe weather, precise altitude adjustments, and frantic ground control vectors to slip through a lethal blockade of elite German interceptors, all without achieving the legendary fabricated kills later attributed to his name? To understand the precise nature of the trap closing around Lieutenant Byers that afternoon, you first have to examine the unforgiving mechanical anatomy of the machine he was flying. The North American P-51 Mustang is historically celebrated as the definitive long-range escort fighter of the Second World War, a marvel of aerodynamic efficiency that allowed Allied pilots to escort heavy bombers all the way to Berlin and back. But that legendary war-winning range was not magic. It was the result of a highly delicate, heavily burdened fuel management system that demanded constant, meticulous attention from the pilot. A fully loaded Mustang carried its lifeblood in 2 internal wing tanks and a precarious 85-gallon fuselage tank situated directly behind the pilot's seat. For the long, grueling trip deep into the heart of the Third Reich, the pilots relied entirely on massive external drop tanks bolted to the underside of the wings. The Packard-built Rolls-Royce Merlin engine, housed in the nose, was a masterpiece of aviation engineering, but it was also fiercely, violently thirsty. When operating at a standard, disciplined cruise setting, carefully balancing the manifold pressure and the engine RPM, the Mustang could sip fuel with remarkable efficiency. However, the moment a pilot was forced to engage in combat, shoving the throttle forward to pull maximum manifold pressure for emergency power, that fuel consumption curve spiked dramatically. A fighter performing aggressive evasive maneuvers, climbing steeply under full power, or running at absolute maximum speed at lower altitudes would drain its tanks at a catastrophic rate. The margin between returning to base and bailing out over enemy territory was often measured in mere gallons. Byers found himself on the wrong, fatal side of that consumption curve through a lethal combination of sudden atmospheric chaos and a seemingly minor navigational error. Over the mountainous, heavily forested terrain of southern Germany, the winter weather of late 1944 was notoriously unstable and deeply hazardous. While escorting a massive heavy bomber formation toward a critical Bavarian industrial target, his squadron was suddenly swallowed by a massive, unpredicted weather front. A towering wall of dense cumulonimbus clouds churning with violent updrafts and spanning tens of thousands of feet into the freezing stratosphere entirely shattered the American formation. In the days before advanced onboard radar, global positioning, or reliable instrument landing systems, maintaining visual contact was the only viable way for a fighter squadron to stay together. In a matter of seconds, engulfed in a blinding white soup of freezing moisture, Byers lost sight of his flight leader. As he desperately banked and maneuvered to avoid a catastrophic mid-air collision in the zero visibility conditions, he inadvertently altered his heading. What he did not realize in the blinding whiteout was that he had flown directly into the teeth of a high-altitude jet stream, a fierce meteorological phenomenon that Allied meteorologists were only just beginning to truly understand. The invisible, roaring tailwind pushed his aircraft significantly further east than his dead-reckoning calculations on his kneeboard indicated. By the time he finally broke out of the turbulent cloud bank into a small pocket of clear, frigid air, he was completely alone, miles away from his designated flight path and dangerously deep inside the heavily defended airspace of the German Reich. Worse still, reacting to the initial panic of the cloud bank and the standard expectation of immediate combat upon losing the formation, Byers had reflexively followed standard operating procedure. He had pulled the mechanical release handles and jettisoned his external drop tanks. Those heavy, drag-inducing metal pods tumbled away into the Bavarian overcast, taking a massive portion of his safety margin with them. He was now operating strictly on internal fuel. Looking down at the mechanical gauges vibrating on his instrument panel, the mathematics of his survival became terrifyingly simple and completely unforgiving. He was hundreds of miles from the nearest Allied forward airfield in liberated France or Belgium. The needles indicating the levels in his internal wing tanks were dropping with a steady, morbid rhythm. Every single minute spent circling to search for his lost squadron, every slight adjustment in the throttle to climb back above the threatening weather systems, was rapidly bleeding away the exact aviation gasoline he needed simply to maintain altitude on the long flight home. The Merlin engine required a constant, heavy flow of high-octane fuel just to keep the 7,000-pound fighter airborne in the thin, oxygen-starved, sub-zero air of 25,000 feet. While Byers was wrestling with his fuel mixture controls and propeller pitch inside a freezing, pressurized cockpit, a completely different type of mathematics was quietly sealing his fate on the ground. Far below him, hidden beneath the dense Bavarian cloud cover that blanketed the landscape, the German air defense network was fully awake and tracking his every move. The Luftwaffe of late 1944 did not rely on pilots aimlessly patrolling the vast skies hoping to stumble upon an intruder. They operated a highly integrated, technologically advanced system of ground control that stretched across Europe. Massive Freya radar installations, featuring sprawling arrays of phased antennas, constantly swept the skies over southern Germany, piercing through the thickest weather. Designed as sophisticated early warning systems, the Freya operators were highly trained to read the electronic echoes bouncing back to their glowing cathode ray tubes. Through the electronic snow and ground clutter, a German radar operator picked up a distinct, solitary blip. It was not a massive box of B-17 bombers. It was a single fighter. To the German air defense network, a single American fighter, separated from the protective, overlapping machine gun fire of the bomber formations and the covering escort squadrons, was the ultimate prize. It was highly vulnerable, completely blind to the forces mobilizing against it, and entirely isolated in a hostile sky. Inside a dimly lit, concrete Luftwaffe command bunker miles away, a specialized fighter control officer began meticulously plotting Byers' exact altitude, speed, and heading across a massive frosted glass map. Using dedicated landlines and radio relays, the controller immediately began vectoring a flight of Focke-Wulf 190 interceptors that were already airborne in the adjacent sector. The German pilots, flying heavily armed fighters that were optimized for rapid climbing and short-range interceptions, were guided with surgical, mathematical precision toward the exact coordinates of the lone Mustang. The German pilots did not even need to establish visual contact yet. The radar operators on the ground were essentially flying the interceptors by proxy, calculating the geometry of the interception and placing them on a direct collision course to ambush the American the moment he exited the cloud system. For Lieutenant Byers, the trap was now fully, invisibly set. The crushing external pressure of the restricted visibility and the tightening, invisible radar net closing around him from below collided violently with the internal, agonizing pressure of his rapidly dropping fuel gauges. He was effectively cornered in 3 dimensions, trapped between the unpredictable atmospheric soup and a technological wall. The standard instinctual reaction of any fighter pilot caught alone behind enemy lines was to shove the throttle entirely to the firewall, push the nose down, and initiate a screaming, high-speed dive for the deck to run away at over 400 miles per hour. But sitting alone in the cockpit, calculating the vast geographic distance to safety against the few remaining gallons sloshing in his tanks, Byers realized that pulling that classic evasive maneuver was a guaranteed death sentence. He simply did not have the fuel required to outrun them on the deck. At that exact moment, the agonizing silence inside his freezing cockpit was shattered by a burst of heavy static. Hundreds of miles away, in highly classified listening posts across the English Channel, the Allied Y Service was constantly monitoring the airwaves. These specialized radio intelligence units listened relentlessly to the Luftwaffe's ground control frequencies. Through the crackling interference of the high-frequency bands, an Allied operator intercepted the precise, clinical transmissions radiating from the German command bunker in Bavaria. The enemy controllers were broadcasting specific heading, altitude, and range vectors. As Allied intelligence officers quickly plotted those intercepted coordinates on their own plotting boards, they realized the horrifying tactical geometry of the situation. The Luftwaffe was actively guiding a flight of interceptors directly onto a solitary, completely isolated American blip. Breaking standard protocol and risking the exposure of their own monitoring positions, Allied ground control keyed a microphone and broadcast a desperate, unencrypted emergency warning on the Common Guard frequency. The transmission punched straight into Byers' leather flying helmet. The voice on the radio delivered a chillingly precise set of numbers, confirming the invisible threat he could not yet see. Multiple enemy aircraft were approaching from his 6 o'clock, climbing fast on a perfect intercept course, and were less than 5 minutes away. The standard expectation in this scenario is immediate, violent combat, but Byers was completely trapped by the cold mathematics of his fuel gauge. Engaging in a high-throttle, high-G turning dogfight with specialized interceptors would drain his few remaining gallons in a matter of minutes. It guaranteed his engine would starve, putting him down in enemy territory, regardless of the duel's actual outcome. He could not dive to the deck to run, and he could not afford to fight. He was forced to make a critical, counterintuitive decision that violated every survival instinct of a hunted pilot. He had to run straight up. Directly above his canopy loomed the anvil-shaped head of a towering cumulonimbus cloud bank, a massive, violent weather system reaching nearly 30,000 feet into the stratosphere. These storm cells were notorious for tearing aircraft apart with sheer turbulence, but right now, that dense, freezing wall of moisture was the only cover capable of masking his radar signature from the Freya operators on the ground. Byers hauled back on the control stick, pulling the heavy Mustang into a brutally steep, inherently dangerous climb. It was an agonizing gamble. He had to shove the throttle forward, deliberately burning a critical surge of his precious aviation gasoline just to overcome the immense drag of gravity. As the aircraft clawed its way upward into the thinning, oxygen-starved air, his aerodynamic margins rapidly evaporated. The airspeed indicator steadily unwound. The fighter began to shudder violently, riding the absolute razor's edge of an aerodynamic stall. If he pulled back even a fraction of an inch too far, the wings would lose their lift, dropping the Mustang like a stone directly into the gun sights of the approaching interceptors. Below him, the dark silhouettes of the pursuing Focke-Wulfs were just beginning to materialize against the gray landscape, their engines straining to close the final vertical gap, but they were seconds too late. With his engines screaming in protest and the airframe vibrating under immense strain, the Mustang finally breached the cloud base. Byers punched directly into the freezing, blinding white of the storm, instantly vanishing from both the visual world and the glowing radar screens, leaving the enemy circling the empty sky beneath him. The instant the Mustang violently breached the cloud base, the visual world was completely and instantly erased. Lieutenant Byers was swallowed whole by an opaque, blinding whiteout of supercooled moisture, plunging the aircraft into a chaotic atmospheric environment where the ambient temperature immediately plummeted past minus 40 degrees Fahrenheit. But the most immediate, overriding threat to his survival was not the freezing temperature, nor the pursuing German fighters miles below. It was the violent, inherent kinetic energy of the storm cell itself, and the catastrophic, inevitable betrayal of his own human physiology. Inside the towering cumulonimbus formation, massive thermal updrafts and violent downdrafts sheared aggressively against the airframe. The 7,000-pound fighter was violently thrown upward, then slammed downward, the aluminum wings flexing and shuddering under immense aerodynamic stress. In this total, disorienting whiteout, with absolutely no horizon, no ground, and no sky to reference, Byers was subjected to the most terrifying phenomenon in high-altitude aviation: severe spatial disorientation. The human vestibular system, the delicate, fluid-filled semicircular canals inside the inner ear that govern balance and spatial awareness, evolved strictly for two-dimensional movement on the surface of the Earth. In a high-performance aircraft maneuvering violently in three dimensions without visual references, the inner ear becomes actively hostile to the pilot. Without a clear visual horizon to correct the sensory inputs, the brain simply cannot distinguish between the actual pull of gravity and the centrifugal forces generated by a banked turn. If the aircraft's left wing dropped slightly and began a slow descending bank, the fluid in Byers' ear would eventually stabilize within seconds, sending a powerful false electrical signal to his brain that he was flying perfectly straight and level. If he reacted to what his body was screaming at him and attempted to, quote-unquote, level the wings based on physical sensation alone, he would actually be throwing the Mustang into a violent inverted dive. This sensory illusion, known among instrument pilots as, quote-unquote, the leans, or the deadly Coriolis illusion, inevitably leads to a graveyard spiral, a tight descending turn that rapidly accelerates the aircraft until the wings are literally torn off by aerodynamic stress. This phenomenon had already killed more aviators in adverse weather than enemy anti-aircraft fire ever could. To survive the next few hours, Byers had to perform an act of supreme, unnatural psychological discipline. He had to completely and utterly ignore the screaming, panic-inducing signals originating from his own inner ear and transfer his absolute trust to a cluster of vibrating, primitive mechanical dials mounted on his main instrument panel. He locked his eyes entirely onto the primary flight instruments, the gyroscopic attitude indicator, which displayed a tiny artificial airplane against a painted horizon line, and the vacuum-driven turn and bank indicator, commonly referred to by pilots as the needle and ball. These instruments were not the advanced digital fail-safe computer screens of modern aviation. They were highly delicate mechanical assemblies of spinning brass rotors, fragile rubber vacuum lines, and small glass tubes filled with kerosene. They were inherently prone to tumbling if the aircraft maneuvered too aggressively, and their mechanical linkages lagged slightly behind the actual real-time movements of the plane. Worse still, the gyroscopes were powered by an engine-driven vacuum pump. If he let his engine RPM drop too low, the vacuum pressure would fail, and his only artificial reference to the horizon would slowly droop and die. Byers was forced to fly the heavy, violently bucking machine with microscopic, agonizingly precise inputs on the control stick and the heavy rudder pedals. Gripping the stick with a white-knuckled intensity, he constantly scanned the gauges: airspeed, altimeter, artificial horizon, vertical speed, processing the raw data, translating it into physical inputs, and fighting the overwhelming physical urge to trust his own senses. Every single second spent inside the turbulent, freezing cloud required maximum cognitive load and intense physical exertion. A heavy hand on the controls would induce a stall or a lethal spin inside the cloud, while a lack of correction would lead to a structural failure. The cockpit was rapidly turning into an exhausting, high-altitude psychological pressure cooker. Meanwhile, miles below the turbulent cloud deck, the tactical situation was rapidly reorganizing into a highly disciplined, mechanized trap. The flight of Focke-Wulf 190 interceptors that had been vectoring for a perfect visual ambush aggressively pulled out of their steep climbs. The heavy, powerful BMW 801 radial engines roared as they leveled off just below the churning gray base of the cumulonimbus cell. The German pilots had lost direct visual contact with the solitary Mustang, and the massive meteorological return of the dense storm cell was actively scattering the radio waves of the Freya early warning radar arrays, effectively blinding the German ground controllers to Byers' precise altitude and heading within the turbulent weather system. However, the Luftwaffe fighter controllers stationed in the heavily fortified command bunkers across Bavaria did not panic. They were highly experienced tacticians dealing with a known, strictly calculable variable. They understood the unyielding mechanical limitations of an American escort fighter operating deep behind enemy lines without the benefit of its external drop tanks. The German tactical doctrine in this specific scenario was highly clinical and brutally pragmatic. They knew that no single pilot could sustain manual, hard instrument flight inside a severe, violently turbulent storm cell indefinitely. The human body and mind were simply not designed for it. The American would inevitably succumb to extreme spatial disorientation and plummet out of the sky in an unrecoverable spin, or the sheer compounding terror of structural icing and rapid fuel starvation would force him to willingly drop his nose and break out beneath the cloud deck to find his geographical bearings. Proceeding on this logical, statistical assumption, the Luftwaffe controllers issued a series of rapid, coded commands over the VHF radio frequencies, ordering the interceptors to establish a highly organized, heavily layered patrol screen. They methodically constructed what was essentially a floating, mechanized net across the Bavarian airspace, a tactic they referred to as a layer cake. Flights of Messerschmitt Bf 109Gs, carrying high-altitude Daimler-Benz engines, took up the upper holding patterns just below the storm base. The heavily armed Focke-Wulf 190s, carrying quad 20mm cannons and optimized for lower altitude energy fighting, established a wider, sweeping grid below them. They were actively building an impenetrable three-dimensional wall of overwhelming firepower across the specific grid squares the American would have to transit. The German pilots paced back and forth across the sky, their heads on a swivel, constantly scanning the gray, churning underbelly of the clouds. They were acting with the supreme, terrifying confidence of hunters who had successfully cornered their prey in a tree. They did not need to chase him into the lethal, turbulent whiteout. They simply had to wait for atmospheric physics, fuel exhaustion, or a single moment of human error to drop him directly into their crosshairs. While the Luftwaffe meticulously laid its trap in the skies over southern Germany, a desperate, entirely silent battle of information was unfolding hundreds of miles away on the English Channel coast. Hidden inside heavily disguised Nissen huts and heavily guarded concrete blockhouses, the operators of the Allied Y service were hunched over glowing radio receivers, their ears pressed tightly to heavy bakelite headphones. These highly classified signals intelligence units, staffed heavily by personnel from the Women's Auxiliary Air Force, were engaged in the relentless, real-time interception of Luftwaffe ground-to-air communications. They did not need to decode complex Enigma ciphers to understand the immediate tactical situation. The German fighter controllers, operating under the immense time pressure of an active interception, were broadcasting their vectors and grid coordinates in standard, unencrypted voice traffic. As the German controllers called out the specific Jägergradnetz, the rigid alphanumeric fighter grid system used by the Luftwaffe to divide the airspace over the Reich, the Allied operators rapidly translated the codes and passed them instantly to plotting officers. In the dimly lit operations rooms, WAAF plotters pushed wooden markers across massive, illuminated Seeberg map tables representing the European continent. As they plotted the positions of the circling Focke-Wulfs and Messerschmitts, a horrifying tactical picture began to materialize on the board. The Allied intelligence officers realized that the Luftwaffe was not simply conducting a random, sweeping search pattern. The German controllers had correctly anticipated Byers' most logical heading for survival. To have any realistic hope of reaching the forward Allied airfields in liberated eastern France or Belgium, Byers had to maintain a generally western trajectory. The map table clearly showed that the Germans were stacking their interceptor squadrons directly across that exact geographical corridor. They were actively constructing a lethal, unavoidable blockade, perfectly positioned across the Mustang's only viable egress route. The Allied controllers were immediately faced with an agonizing, impossible dilemma. They knew exactly where the trap was, and they knew the lone American pilot was flying completely blind directly toward it. However, they could not continuously broadcast warning vectors to Byers. Doing so would not only heavily compromise the extreme secrecy of the massive Allied signals intelligence network, alerting the Germans that their frequencies were entirely compromised, but it would also be tactically suicidal for the pilot. If Byers broke radio silence to acknowledge the warnings or ask for specific headings, the German radio direction finding stations, the highly accurate Pylar network, would instantly triangulate his transmission, pinpoint his exact location inside the storm cell, and allow the interceptors to concentrate their forces directly beneath him. Byers was completely cut off from the massive Allied intelligence apparatus that was helplessly watching him fly toward his own execution. He was locked inside his freezing cockpit, isolated by a wall of static, entirely unaware of the massive, coordinated ambush waiting for him just thousands of feet below his floorboards. Inside the violently bucking cockpit of the P-51, the massive adrenaline spike of the initial evasion was rapidly fading, replaced by the crushing, highly analytical reality of a high-altitude endurance test. Having successfully stabilized the aircraft on the gyroscopic instruments, Byers forced himself to divert his attention from the artificial horizon just long enough to assess the mechanical state of his machine. He looked down at the main fuel gauges mounted on the lower right instrument panel, indicating the levels in his internal wing tanks. The needles were resting dangerously low, vibrating steadily downward with a morbid, unrelenting rhythm. The massive, fuel-heavy climb required to escape the initial interceptors, combined with the catastrophic loss of his external drop tanks, had absolutely devastated his reserves. The mathematics of his survival were no longer calculated in airspeed or miles per hour, but in absolute strict fuel consumption rates. To survive, he had to drastically alter the operating parameters of the massive Packard-built Rolls-Royce Merlin engine, roaring just a few feet in front of his boots. He reached forward with his left hand, gripping the heavy mechanical levers of the throttle quadrant. In a standard combat scenario, a pilot shoves the throttle fully forward to the firewall, demanding maximum manifold pressure, often exceeding 60 inches of mercury, and high RPMs for raw speed and maneuverability. Byers had to do the exact, highly dangerous opposite. He slowly, deliberately pulled the heavy throttle lever back, actively starving the engine of its power, watching the manifold pressure gauge drop to an agonizingly low setting of just over 25 inches. He then adjusted the propeller pitch control, flattening the angle of the massive metal blades to reduce the engine's revolutions per minute to a slow, stuttering chug. Finally, he reached for the highly critical mixture control lever, pulling it firmly back into the auto lean detent. He was actively starving the massive V12 engine of its high-octane aviation gasoline, restricting the fuel flow until the engine threatened to violently cough, sputter, and stall, giving it just barely enough combustible vapor to keep the heavy propeller turning in the thin air. He had successfully established his maximum endurance cruise setting. The Mustang's airspeed rapidly decayed, wallowing sluggishly, flying just a few knots above its absolute stall speed. He was artificially stretching out his fuel supply, wringing every possible second of flight time from every single remaining drop of gasoline. But this desperate mechanical measure carried a brutal, immediate secondary cost. The Merlin engine, when running at high combat power, generates immense amounts of excess thermal energy, a portion of which is diverted through the liquid cooling system to provide critical heat to the cockpit. By throttling the engine back to a near-idle, fuel-sipping state, Byers effectively shut down his only source of warmth. At 25,000 feet inside an active storm system, the ambient temperature is inherently, profoundly lethal. Without the radiant heat from the engine block, the temperature inside the uninsulated, thin aluminum shell of the cockpit went into freefall. Frost rapidly began to coat the glass faces of the instrument panel, obscuring the dials. Thick condensation froze solid against the Perspex canopy and built up inside the rubber corrugated hoses of his oxygen mask, threatening to choke off his air supply. Byers was not wearing the heavy, electrically heated flight suits issued to the high-altitude heavy bomber crews. He was wearing a standard, relatively thin leather flight jacket over his standard uniform. He rapidly began to suffer the agonizing, degrading physiological effects of severe cold exposure. He began to shiver violently, a deep, uncontrollable, bone-rattling spasm that made it incredibly difficult to maintain the microscopic, highly precise control inputs required to keep the aircraft level on the delicate gyroscopic instruments. His manual dexterity rapidly degraded. The heavy leather boots resting on the rudder pedals went completely numb, forcing him to fly the aircraft by the raw pressure against his thighs, rather than the actual feel of his feet. He was enduring a freezing, oxygen-starved purgatory, willfully subjecting his own body to severe hypothermic conditions, deliberately prolonging his agonizing exposure to the lethal atmospheric environment simply to keep the engine turning for a few more miles. As the clock ticked forward, time itself began to stretch and distort inside the vast, gray expanse of the Bavarian sky. 30 agonizing minutes passed, then 45, then a full, brutal hour. Deep inside the freezing cumulonimbus cell, Byers maintained his agonizingly slow, perfectly level, fuel-starved crawl toward the west. But miles below the cloud deck, the dynamic of the hunt was beginning to undergo a fundamental, highly stressful shift. The clinical, arrogant confidence of the German fighter controllers, who had so perfectly orchestrated the initial ambush, was beginning to crack under the mounting pressure of prolonged uncertainty. The dozens of FW-190s and BF-109s making up the lethal blockade were continuously flying high-speed patrol patterns, constantly weaving, banking, and accelerating to maintain their precise positions within the designated grid squares. The massive, supercharged aviation engines powering the German interceptors were incredibly powerful, but they were also inherently ravenous. The heavy BMW 801 radial engines and the Daimler-Benz inverted V12s were burning through their internal fuel reserves at a rapid, uncompromising rate simply to maintain their defensive posture in the sky. Unlike the American fighters designed for deep penetration escort missions, the German interceptors were point defense fighters, designed to launch, climb rapidly, engage, and land within a highly compressed time frame. Their internal tanks held far less fuel than the Mustang. Hundreds of miles away on the English coast, the Allied Y-service operators monitoring the radio traffic began to document a distinct, highly revealing change in the tone of the enemy transmissions. The precise clinical commands of the German ground controllers were being rapidly replaced by sharp, frustrated inquiries from the flight leaders in the air. The German pilots were demanding updates. Where was the American? Did he crash into the mountains? Had he miraculously slipped past the perimeter? The ground controllers, staring blankly at glowing radar screens that showed absolutely nothing but the massive static return of the storm cell, had absolutely no answers to give. They could only order the interceptors to hold their positions and continue the sweep. But the German pilots were increasingly forced to drop their eyes from the gray cloud deck to monitor their own rapidly dropping fuel gauges. Inside the German cockpits, the small red warning lamps indicating low fuel reserves were beginning to flicker on. The inherent advantage of the Hunter was steadily eroding. What had begun as a perfectly calculated, overwhelming technological ambush was rapidly degrading into a desperate, grinding war of attrition. The American was completely trapped in a freezing, blinded state, navigating entirely by primitive gyroscopes, but by absolutely refusing to drop out of the clouds and surrender to the blockade, he had inadvertently inverted the tactical pressure. He was actively forcing the Luftwaffe to burn their own highly precious, increasingly scarce fuel reserves to maintain the dragnet. The entire massive engagement had devolved into a pure, unromantic, highly stressful mathematical standoff. It was two heavily armed sides, separated by thousands of feet of opaque, freezing vapor, both staring intently at the vibrating needles of their respective fuel gauges. The sprawling sky over the Third Reich was a massive, incredibly hostile arena, but it was also a strictly finite container of kinetic energy. The tactical planners on the ground and the exhausted pilots in the air all understood the same brutal, inescapable arithmetic of aerial warfare. This high-altitude game of cat and mouse could not continue indefinitely, because in this brutal equation, someone was going to run dry first. The answer to that brutal equation, who would run dry first, was ultimately buried beneath decades of veteran folklore and distorted unit rumors. For years, the popular legend insisted that when Byers finally ran out of time and altitude, he dropped out of the overcast with his 6 50 caliber machine guns blazing, aggressively dogfighting his way through the German blockade and scattering the burning wreckage of multiple interceptors across the Bavarian snow. It is a perfect cinematic narrative of American aerial supremacy, but it never happened. When historians finally stripped away the post-war mythology and cross-referenced Byers' original classified post-mission debriefing with the surviving Luftwaffe quartermaster loss records for that specific grid sector, the empirical truth of the engagement was revealed to be far more profound. On that afternoon, in that precise corridor of airspace, 0 confirmed aerial victories occurred. Not a single shot was fired by either side. The American pilot did not blast his way out of the trap. He outlasted it, aided by a catastrophic hidden flaw in the German war machine. While the Focke-Wulfs and Messerschmitts possessed overwhelming tactical advantages in firepower and positioning, Their entire operational reality was built on a crumbling logistical foundation. By the winter of 1944, the relentless Allied strategic bombing campaign against German synthetic oil plants had effectively severed the Luftwaffe's arteries. The German fighter forces were suffering from a crippling systemic shortage of high-octane aviation gas. They simply did not have the daily fuel allocation to maintain a prolonged, high-power blockade. Down below the cloud deck, the German flight leaders were forced into an agonizing calculation. The red warning lamps on their instrument panels were no longer flickering. They were burning steadily. Their high-performance engines were starving. Bound by rigid operational limits and the strict necessity to preserve their irreplaceable aircraft, the Luftwaffe controllers had no choice but to issue the recall order. One by one, the interceptors banked sharply away, dropping their noses and diving back toward their respective airfields, forced to abandon the kill, not by superior marksmanship, but by their own nation's massive logistical collapse. Minutes later, the violent turbulence hammering the Mustang suddenly ceased. The thick, freezing whiteout fractured, and Byers broke out into the blinding, high-altitude sunlight. He looked down through his frosted canopy, expecting to see a swarm of enemy fighters climbing to meet him. Instead, he saw only an empty, sprawling sky. The mechanized wall of interceptors had simply vanished. The immediate tactical threat was completely gone, neutralized by the brutal economics of a dying empire. But the unforgiving laws of physics remained entirely intact. The enemy had retreated, but Byers was still hundreds of miles from friendly lines, alone in an agonizingly slow aircraft, and his own internal tanks were now practically dry. He finally crossed the Rhine River, slipping out of hostile airspace and over liberated eastern France. Below him, the scarred, artillery-pocked landscape of the Allied advance rolled past, but his salvation was entirely geographical, not mechanical. Inside the freezing cockpit, the needle on his main fuselage tank was no longer vibrating. It was resting dead flat against the zero peg. The rhythmic, reassuring roar of the Packard V12 engine had been his only anchor for the last 4 hours. Suddenly, the engine violently stuttered. A violent mechanical cough shook the airframe, followed by a terrifying, hollow backfire. And then, absolute, deafening silence. The engine had starved. The massive four-bladed Hamilton Standard propeller out front stopped driving the aircraft and began to lazily windmill in the slipstream, instantly transforming from a source of thrust into a massive aerodynamic brake. At over 15,000 feet, Lieutenant Byers had just become the pilot of a 7,000-pound unpowered block of aluminum. A P-51 Mustang is engineered for high-speed, powered pursuit. Without the thrust of its 12 cylinders, its glide ratio is brutally steep. Gravity immediately asserted its absolute dominance. To prevent an immediate, fatal aerodynamic stall, Byers had to shove the control stick forward, pointing the heavy nose down, deliberately trading his remaining altitude to maintain the airspeed required to keep the wings flying. The high-pitched hiss of the freezing wind tearing across the Perspex canopy replaced the roar of the engine. Below him, the patchwork fields of the French countryside rushed upward at a terrifying rate. Peering through the frost-rimmed glass, he spotted the unmistakable geometry of an Allied advanced landing ground. A crude, temporary runway made of interlocking, pierced steel planking, hastily carved out of a farmer's field by combat engineers. But spotting the runway was only a fraction of the problem. A dead stick landing in a heavy fighter offers exactly 0 margin for error. There is no throttle to push forward if the approach is too low. There is no second chance to pull up and execute a go-around. You have exactly one mathematical attempt to put the heavy machine on the dirt. This required a flawless, continuous calculation of descent rate, drag, and kinetic energy, executed by a pilot whose body was actively shutting down. Byers was severely hypothermic. His hands, locked into rigid claws inside his thin leather gloves from hours of sub-zero exposure, could barely grip the control stick. His legs were entirely numb from the knees down, making the heavy rudder pedals feel like distant, disconnected blocks of iron. Furthermore, without the engine driving the hydraulic pumps, the flight controls became incredibly heavy, requiring raw, agonizing physical strength to manipulate. As the runway threshold rapidly expanded in his windscreen, the physical exertion required to muscle the unpowered fighter into a proper glide path pushed him to the edge of blacking out. He manually deployed the heavy landing gear, the massive struts dropping and locking into place with a violent jolt that sent a sickening shudder through the dying airframe. He was coming in fast, dropping like a stone over the tree line. The ground rushed up in a blur. With his absolute last reserve of physical strength, Byers hauled back on the heavy stick, flaring the long nose just inches above the steel matting. The tires slammed onto the runway, screeching against the metal as the fighter bounced once, settled hard, and violently decelerated. The Mustang rolled to a halt at the far edge of the dirt strip, the windmilling propeller finally clicking to a complete dead stop. Sitting in the sudden, eerie quiet of the European afternoon, surrounded by the smell of hot oil and freezing aluminum, Byers had survived the absolute, literal limit of the machine's endurance. When the heavy Packard engine finally cooled and the Allied ground crews rushed to the silent aircraft, the foundation for a post-war legend was already being poured. In the decades that followed, popular culture would inevitably twist a flight like this into a triumphant cinematic narrative. We have been conditioned to imagine the solitary aviator stepping out of the cockpit, having shot his way through a dozen enemy interceptors with blazing machine guns, acting as a modern knight who conquered the hostile skies through sheer willpower and superior marksmanship. But when we look directly at the dry, yellowed pages of the 8th Air Force combat logs and cross-reference them with the surviving Luftwaffe interception reports, a far more compelling reality emerges. The survival of Lieutenant Byers is not a simplistic tale of a lone American warrior defeating a faceless enemy horde. It is the ultimate illustration of the unglamorous, strictly mathematical reality of the strategic air campaign over Europe. Life and death in the sub-zero stratosphere were rarely decided by who had the fastest trigger finger or the most heroic spirit. They were dictated by atmospheric science, rigidly calculated fuel consumption rates, and the invisible, desperate architecture of radar intelligence. This was a purely industrial war fought on a rigid three-dimensional grid, where a sudden barometric shift or a severely leaned-out fuel mixture was just as critical as a heavily armed Focke-Wulf. The German pilots who hunted him were not simply generic targets waiting to be outflown. They were highly capable tacticians, operating a sophisticated defense network, ultimately neutralized by their own nation's collapsing logistical foundation. Their high-performance machines were starved of aviation gasoline before they could ever close the trap. The outcome of the engagement was largely decided by bombed-out synthetic oil refineries and broken supply lines hundreds of miles away from the actual clouds. By stripping away the heavily romanticized pulp fiction of the era and relying entirely on the unadorned, factual records of both nations, we do not diminish the immense psychological and physical endurance required to fly these missions. Instead, we reveal a deeper, far more authentic history of aerial warfare. It exposes a conflict where the ultimate margin of survival was completely stripped of cinematic glory, governed instead by the cold, precise, and unforgiving mechanics of flight. In the unforgiving logistics of the Second World War, the greatest victory a fighter pilot could achieve was sometimes just managing to land an empty airplane.